Today we're going to look at section 3.1 of chapter 3, and chapter 3 is going to be introducing inequalities. So today we're just going to talk through what these inequalities are and how they work. So just as a reminder, your inequality symbols, greater than symbol looks like this. Greater than or equal to, obviously would have that equal sign underneath. Less than looks like this. And then less than or equal to. And it is important that you memorize these symbols and know how to read them correctly. First example, the question is each number a solution of this inequality right here, which we would read x greater than negative 14.6. And so what you're going to do is on A, the question is negative 15 greater than negative 14.6? So you're just taking this number and you're plugging it into your x. So is negative 15 greater than negative 14.6? That's the question. And remember with negatives, the bigger the number, the further it is down on the number line, which means it's further away from 0. So the further you are from 0, the smaller the number is. So is negative 15 greater than negative 14.6? No. So negative 15 would not be a solution. Okay, let's look at B. The question is 0 a solution of this inequality? So I'm taking 0 and I'm plugging it into x, and we're wondering, is that true? Is 0 greater than negative 14.6? It is, yes. 0 is greater. Okay, negative 36 over 3. We can simplify this number to negative 12. So the question is negative 12 greater than negative 14.6? Well, yes, negative 12 sits closer to 0 than negative 14.6 does on a number line. So negative 36 over 3 would be a solution. The last one, that's kind of hard to read, is the square root of 16. And you can simplify the square root of 16 if you do that on your calculator or you know it in your head. Square root of 16 is 4. So is 4 greater than negative 14.6? Yes, because a positive number is always greater than a negative number. Okay, so that's going to be the first part, determining is a number a solution of the inequality. Now, same idea on the second and third example, only the difference is now we have more on our inequality, so we're going to have to do some adding and subtracting, multiplying, dividing, etc. Okay, so the question is x equals 3 a solution of this inequality? So we're going to take this 3 right here, and we're going to plug it in to our x. So we're going to write 12 minus 5. Remember, when you plug in, you do parentheses. And then the question is that greater than or equal to negative 5? And this is not solving. Notice we have no variables left. We are just going to simplify this. We're evaluating. And so when you simplify, you have to keep in mind PEMDAS. So I need to multiply first. So this is 15. Bring down the minus. Bring down the 12. Bring down that symbol and negative 5. And then 12 minus 15 is negative 3. So the question is this a true statement or not? Is negative 3 greater than or equal to negative 5? Negative 3 is closer to 0 on the number line, which means it's bigger. So that is true. So the question is x equals 3 a solution? Yes. Same idea for the next one. So on the second example, the question is x equals negative 4, is it a solution of this inequality? So we're going to take this negative 4 and we're going to plug it into our x. So we're going to write negative 6. Instead of x, I'm plugging in negative 4 in parentheses. Minus 13 is less than 10. And then we're going to simplify using PEMDAS. I'm going to multiply first. So that's a positive 24. Bring down minus 13 and then less than 10. 24 minus 13 is 11. So the question is that true? Is 11 less than 10? It is not true. So is x equals negative 4 a solution to that inequality? No, because it didn't hold true when we plugged it in. Next up is how we graph inequalities. And so here's what you need to pay attention to. When we're graphing, you're going to have circles on your graph. Notice that this circle is open. And an open circle means that we don't want to include the value. So if we're talking about graphing x less than 3, we're not including 3, so our circle is going to be open. However, if I have an equal to on my inequality, right there, that equal to, then I want to include that value, and so I would shade in my circle, and we call that a closed circle. Okay, so what I want you to write down is if I have a less than symbol or a greater than symbol, I don't want to include the value, so that's going to be an open circle. If I have less than or equal to or greater than or equal to, I do want to include the value, so that's going to be a closed circle. Okay, the second part of graphing is knowing which way to shade. So if it's a less than symbol, we need to shade to the left where the values are less. So that's where we're going to shade to the left. If it's a greater than symbol or greater than or equal to, we're going to shade to the right. So it's important when graphing, you need to know when to do open and closed circles and shading which direction. Okay, so we're going to graph m is greater than -4. So you're going to put your circle at the value that it is. So we're going to put our circle at -4, and this is going to be an open circle because we are not including it. And then this is a greater than symbol, which means I'm going to shade right. And I'm putting an arrow because this would go on and on and on. So it doesn't stop. So that's the graph for m greater than -4. The next graph, t is less than or equal to 6. I'm going to put a circle at 6. This time, it's also equal to, so I need to close in my circle. And this is a less than symbol, so for less than, I'm going to shade left. Again, I'm putting an arrow to show that it's going on and on and on. Now, we're going to look at a graph, and we're going to write down the inequality for it. Okay? So here's my suggestion. What I would always do first when I'm doing this is I would put my variable, so I'm going to put my x, and then I would put the value that my circle is sitting at, which is -1. Now, I need to look at my circle. My circle is closed, so I know I'm going to have an equal to part. And then we are shading to the right, and everything to the right is bigger or greater, and so that's going to be my symbol. And so there's my inequality for the graph above. My second graph, again, I'm going to write my variable first, and then I'm going to write the value that or the number that my circle is sitting at, which is -8. And it's helpful if you always put your variable on the left, put your number on the right. This is an open circle, so I don't need an equal sign. And I'm going to the left, so I need my symbol to be a less than symbol. And if you'll notice, if you get in a habit of always writing your variable on the left, then what you should notice is your shading is always going in the direction that your inequality is pointing. So my inequality is pointing to the right, I'm shading to the right. My inequality is pointing to the left, I'm shading to the left. Only follow that if your variable is on the left side of your inequality. And really, you all should be putting your variable on the left side, and so this is something that you can follow. Okay, now we're going to do the same thing. Write the inequality for the graph. So again, I'm going to write my variable down on the left. I'm going to put the number that the circle is sitting at on the right. This is an open circle, so it's not also equal to, and it's greater than, so I'm going to the right, which means I'm pointing my inequality symbol to the right. Last one like this, again, I'm going to write down my variable, and then I'm going to write the number it's sitting at, which is 0, to the right. This is a closed circle, so it's also equal to. I'm going to the left, which means I'm going less than, or my point is going to the left. Okay, next up, we're going to look at a sentence, and we're going to write an inequality to model it. So we need to define a variable, so this is the first thing we're going to do, and then we'll write our inequality. So we have a bus can seat at most 48 students. So we're talking about students, the number of students on a bus. So let's let S be our students. And then just like we did the graphing, we're going to write our letter, and then we're going to write the number to the right. Okay? And this says a bus can see at most. And sometimes what's confusing about inequalities is you look at this and you go most greater than. But you have to think about what it means. If a bus can see at most 48, that means that's the maximum. So I can have 48, but I cannot have more than that. So I need my students to be less than or equal to 48. Next, it says in many states you must be at least 16 years old to obtain a driver's license. So we have this number 16 that we're going to use, and that represents our age. So we're going to let A be our age. And then to set this up, we're going to write our variable, and we're going to write our number, and then we need to figure out what's the inequality symbol that goes there. So does your age need to be less than or equal to 16 to be able to drive, or greater than or equal to 16? Well, we know it's equal to, and if you have to be at least 16, that means you have to be 16 or more. So we want that to be a greater than symbol. Whoops. Okay, next. It is not safe to use a light bulb of more than 60 watts in many light fixtures. So 60 is our number, and that is representing our watts. So we're going to let W be our watts. And so we're going to write our variable, then we're going to write our number 60, and then we're going to figure out what our inequality is. So it's not safe to have a light bulb of more than 60 watts. So our watts could equal 60, but we don't want our watts to be more than that. So we want to be less than 60 for it to be safe. Lastly, it says at least 350, there's our number, students attended the band concert Friday night. So S is going to be our students. And again, we're going to write down S, and we're going to write down 350. And it says at least 350 students attended. And so a lot of times we see this at least, and we want to put a less than symbol. But let's think about what that means. If at least 350 attended, that means there was probably more than that there, or equal to. So 350 was the minimum. So the students could be more or equal to 350. To finish this out, we're going to just rewrite each inequality with the variable on the left. And again, you need to get in a habit of always writing your variable on the left so that you can graph accurately. So when you rewrite it, you're going to put your X there and your 8. And all you need to look at is what is your inequality symbol eating above? It's eating the X. So down here it needs to eat the X. Next, I'm going to put my X, put my -1. My inequality symbol is eating my -1, so it needs to eat my -1 here. On C, rewrite it, X, and then 5/3. My inequality is eating my X, so it needs to eat my X here. And lastly, X and 0, it's eating the 0. It needs to eat the 0 here. And that concludes our inequality 3.1 notes.